Study on performance of thermoelectric generator in living room usage. Do you know that about 2/3 of the energy we use get wasted in form of waste heat, and some estimate that nearly 60% of energy are wasted into atmosphere. Scary as it sounds, with climate change, finding a way to capture this energy is of vital importance. Thus, this is where a device called Thermoelectric Generator or TEG come in. These devices contain thermoelectric material, which when you take this material and you apply temperature difference across them, then the electron want to flow from the hot end into the cooler end. And this thermally induced electric current can be used to power a circuit, converting heat directly into electricity. This phenomenon, where a temperature difference can create a voltage, is known as feedback effect. Now, this already used one example in the spacecraft, where they take a lump of something that will be hot for a really long time, like strontium-90, attach thermal electric around it, connect some wire, and you have a generator that can be scaled to whatever size and shape you want. And because there are no moving parts, it is importantly reliable. So, it sounds simple, but one big problem is that the voltage produced is absolutely tiny, and this is cause it low efficient. Nowadays, we are attracted more interest in smart home and room being equipped with sensor and Internet of Things or IoT devices. Commonly, these devices doesn't need any large amount of power. So, it is crucial along with global effort to reduce energy consumption. Future buildings are heading toward passive house that require significantly less energy for climate control. To ensure we can harvest continuously amount of heat in a living space, a passive solar heating come up from our sun directly contact with room wall that produce thermal radiation, thus generating electricity by harvesting unused or waste heat present in a room. It could also be a good solution to power these devices. There are plenty of thermoelectric modules available on the market, which come out with various output power and sizes, depending on its usability. By selecting this commercial module, we can collect the output value from the manufacturer parameter data. But in this case, the parameter value is based on the room space, which have different temperature gradient. By comparing the data using numerical simulation method with all the equations from thermoelectric formula, we can obtain and analyze the device performance easily, and it can be proved. Thus, from the result, we can select the suitable module and design the TEG system operate for specific application. For instance, living room space. So, this is exactly my research going to do. By selecting this thermoelectric module, we are able to calculate and analyze what is the potential and feasibility of the TEG devices performs to be placed in living room. We also want to predict how many of these devices should be placed in order to design the most suitable system in living room. That's all for me. Thank you for watching.